Hello everyone, welcome to UTME chemistry class with Top Scores e-learning. I am Chidima, your chemistry tutor. In today's class, we'll be exploring the topic air, and we'll be looking at the objectives of the lesson, and they include 1. Candidates should be able to deduce reasons for the existence of air as a mixture. 2. Candidates should be able to identify the principle involved in the separation of air components. 3. Candidates should be able to deduce reasons for the variation in the composition of air in the environment. 4. Candidates should be able to specify the uses of some of the constituents of air. Now, moving ahead into the lesson, we'll look at the definition of air. Air is defined as a mixture of gases composed mainly of nitrogen and oxygen with small amounts of carbon dioxide, noble gases, and water vapor. I take that again. Air is a mixture of gases composed mainly of nitrogen and oxygen with small amounts of carbon dioxide, noble gases, and water vapor. Now we'll look at the percentage composition of air by volume. Nitrogen is about 78%. It has the highest composition. Then we have oxygen. Oxygen is 21%. The next is carbon dioxide. Carbon dioxide is about 0.04%. We have noble gases. Now these noble gases include helium, argon, krypton, xenon. These are examples of the noble gases present in air, and they make up about 1%. We also have water vapor. Now the composition of water vapor is variable. We also have dust particles. The composition of dust particles is also variable. Now the next thing we'll consider as we move ahead in the lesson is the evidence that air is a mixture. The reasons for the existence of air as a mixture. Now, you would recall in one of our previous lessons that we defined the mixture as a substance that is made up of 2 or more constituents, which can be easily separated by physical methods. So, air is a mixture, and one of the reasons air is a mixture is because the constituents of air can be separated easily by physical method. This is the first reason for the existence of air as a mixture. Its constituents can be separated easily by physical methods. For example, remember one of the separation methods or techniques we looked at in our previous lesson is fractional distillation. So fractional distillation is the method which is used to separate air into its physical constituents. So we also have another evidence for the existence of air as a mixture. Now, the constituents of air retain their individual properties. The constituents of air, they retain their individual properties. Now, you remember that we said air is made up of nitrogen, oxygen, carbon dioxide, noble gases, water vapor, and the rest of them. So, each of these constituents, they retain their individual properties. Now, carbon dioxide, for instance, has an affinity for caustic soda, which is sodium hydroxide. So, even as carbon dioxide is one of the constituents of air, it still has that affinity for caustic soda. It doesn't lose its affinity for caustic soda because it is now one of the constituents of air. So the way carbon dioxide in air behaves is the way an isolated carbon dioxide still behaves. It retains its individual property. We also have oxygen. Oxygen has oxidizing property. So oxygen in air also retains its oxidizing property. Then we have nitrogen and rare gases. These gases also retain their inertness, their unreactiveness, even as they are part or constituent of air. Now, another evidence to support that air is a mixture is that the composition of air cannot be represented by any chemical formula. We would also recall in one of our previous lessons that we said compounds are represented by chemical formulas. But air, even though it's made up of some substances, it cannot be represented by a chemical formula. The composition cannot be represented by a chemical formula, as in the case of a compound. So the composition of air varies from place to place. It's not the same everywhere. So this is the reason the composition of air cannot be represented by a chemical formula. Unlike we have water, for instance, the chemical formula for water is H2O. So wherever you go in the world, the formula for water is H2O. Unlike air could vary from place to place. Now, another evidence to support that air is a mixture is that the different constituents of air, when mixed together under ordinary conditions, do not show evidence of any chemical combination. The different constituents of air, when mixed together under ordinary conditions, do not show any evidence of chemical combination such as heat production or volume change. So the mixture obtained will resemble ordinary air in every way. There's no heat change, no volume change, no heat production, no volume production or change. So these are some of the evidences or reasons for the existence of air as a mixture. Moving ahead, we look at the uses of air constituents. The uses of air constituents. Now, the first one we're looking at is nitrogen. Nitrogen is useful in fertilizer production, is useful in the production of ammonia, food packaging, and it also prevents the oxidation and spoilage of food. Nitrogen is used in fertilizer production. We all know the popular fertilizer NPK. It's also used in production of ammonia. It's used in food packaging. It also prevents oxidation and spoilage of food. I also want to add that nitrogen in air acts as a diluent. It helps to dilute the air, because without nitrogen in the air, it would be practically impossible to even light a matchbox. Everything will go up in flames. So nitrogen acts as a diluent. Another use of oxygen is that oxygen is useful in respiration. Oxygen is also one of the constituents of air, and it is useful in respiration. It is also useful as a life support system and oxygen therapy. Liquefied oxygen that is stored in steel tanks is used to aid patients who have breathing problems in various hospitals. Oxygen also supports combustion. That is, it's also useful in removing impurities during steel production. We have carbon dioxide. Carbon dioxide is useful in photosynthesis. Green plants make use of carbon dioxide for photosynthesis. Carbon dioxide is also used in production of fire extinguishers, and is also useful in the carbonation of beverages. Carbon dioxide adds fizz to beverages. We now go to argon. Argon is one of the noble gases, and it is useful in welding. Argon is useful in welding. It is also used in gas-filled electric lamps because it helps to prevent oxidation of the lamps. Now, a mixture of krypton and xenon is useful in the photographer's flash tube for taking high-speed pictures. Helium, neon, and argon give out colored lights when a high voltage current is passed through them under low pressures. So those big colorful advertisement signs we see on the road, they are made up of helium, neon, and argon. We also have that helium is used in observation balloons because it is non-combustible and almost as light as hydrogen. Then a mixture of helium and oxygen are used by divers. So these are some of the uses of the various constituents of air. We'll go for a short break and we'll be right back.